So morning, my name is Paul, and I'm the director of this community center. And we are very glad to have this Jeremy Burden.
Correct.
The president of this association.
Yep.
Give us this seminar about the photos. Solar eclipse. Yeah, very secure. We have 7 people here. For some reason, people, not everybody. But I think some of them are still on their way because many of them never been here. So we take time for them to find this place.
I usually take my time, so okay. Welcome everybody. Thank you for coming out. I've spoken at a lot of different venues. This is everyone's unique. Everyone's different. So I don't know if I've ever had a stage with this much room on it before I was presenting. So obviously I got plenty of room to maneuver here, but a lot of space in this building, a lot of space in this facility. So it's great to be here. So happy Easter, everyone! Thank you for coming out. We got a lot going on this time of year. March is winding down. We got March Madness. We got the Easter holidays, spring break, and of course, we'll talk about the solar eclipse coming up. I've been giving this presentation for a couple of years now, and I'm calling this eclipse. Solar eclipses are very rare and very fleeting. I'm calling this one a heartbreaker, and I'll explain why as we get into this. But before we do, just a quick background on who I am and our organization. So we're the Memphis Astronomical Society, and we're a nonprofit public service organization that basically studies and promotes interest in astronomy and related sciences. Not astrology, astronomy. So it's the science of how things work in the heavens. Not only the sun and the moon, but stars, planets, galaxies, celestial events. We've been around for 70 years. We just celebrated our 70th anniversary. Not me, but our organization. If you'd like to learn more, we have some postcards up here. We do, you become a member. We meet once a month. We do dark sky observance sessions. We do events like this for community centers, libraries, sometimes schools. And basically, we were founded in the early 1950s by a group of teenagers. Most of them are gone now. But it's still about kind of finding the youth that have that passion and that interest and that energy for astronomy to kind of pass on the legacy, if you will, to the next generation. Again, information is there, and if you want to join or just subscribe to our email list, we got a QR code for that. So anyway, I'm the current president. I got a couple of my Astro colleagues, or Astro brothers as I like to call them here, to kind of help me with this presentation as well. So they're a part of this community. So we got Milo, we got Brian, you probably know them. So again, that's who we are. So to start off with, let's just do a couple of basic fundamentals. So the moon orbits the Earth once every 29 and a half days on average. And we are past full. We are now reaching basically third quarter stage. So it goes counterclockwise if you're looking top down. And the punchline is that it will be new on April 8th. And a new moon occurs, of course, when the moon is between the Earth and the Sun. And it just so happens that this particular new moon, we have a rare alignment where the moon gets in front of the sun and blocks out the sun's light for a couple of minutes during the day, if you're in a specific location on Earth. So you can see in this diagram here that we have two parts of the moon's shadow. The wider part is the penumbra that covers about 4,000 miles, or about half of the daylight side of the Earth. And then the umbra shadow is very small. It's only about 100 miles wide, give or take. And that's where all the action is. Now, the moon orbits the Earth every 29 and a half days. So you ask yourself, why don't we get an eclipse every 29 and a half days? And it turns out that the planes of the moon's orbit and the Earth's orbit are not perfectly aligned. And if we do this kind of with two hoops here, if they were aligned like this, in a perfect plane, then we would get an eclipse every new moon or every full moon. In reality, they're actually aligned something like this. So there's a 5-degree angle separating the plane of the moon's orbit around the Earth with respect to the plane of the Earth's orbit around the sun. So most of the time, during a new moon or a full moon, the moon is either above or below the plane of the Earth's orbit with respect to the sun. So the moon's shadow misses us. I've actually got a better illustration diagram to illustrate that. So here you see the moon and the earth in kind of their relative sizes in space. You don't really think about this, but the moon is really far away. And again, most of the time during the new moon, the moon's shadow misses the earth. So that's why we don't get an eclipse every month. However, every once in a while, where the planes intersect, called a node, if the moon is located at a lunar node and it's new, then we have the conditions for an eclipse to take place, a solar eclipse. How often does that happen? On average, about once every 18 to 24 months. So to look at this further, three things need to happen simultaneously in order for a solar eclipse to occur. So number one is that the moon, of course, needs to be new, meaning that it's located between the earth and the sun. It will be on April 8th. The second thing that needs to happen is that it needs to be located at a lunar node, where the points, where those two planes intersect. Again, the Earth's orbit and the moon's orbit. If it's located here, then the shadow misses us. Most of the time that happens. But if it's at a lunar node and it's new, then we have the conditions for an eclipse. Now the third thing that needs to happen is that it needs to be perigee. So the Earth's orbit, or the moon's orbit around the Earth, is not a perfect circle. Kepler's first law of planetary motion is slightly elliptical. So there are certain times when the moon is closer to the Earth, we call that perigee, and then there are times when it's further away, we call that apogee. So if the moon is at perigee, and it's new, and it's located in a lunar node, then we have the conditions for a total solar eclipse, which is going to happen on April 8th. Now, the sun is really big. 99% of all the matter in our solar system is the sun. And you see on this diagram here, Earth is very small, and the moon is even smaller yet. It's on a sequence up here. The moon is just a tiny speck compared to the size of the sun. In fact, you would need to line up 400 moons equal the diameter of the sun. I have to stack 400 moons consecutively to equal the diameter of the sun. So when you hear that the moon is 400 times smaller than the sun, it's really talking about the angular size of the moon if the sun and the moon are at the same distance. Interestingly enough, we happen to live on a planet where even though our star is 400 times larger than our moon, it's also 400 times further away. So if I'm looking at this, the sun is 400 times further away, even though it's 400 times larger than our moon, which is 400 times closer. So from our vantage point on Earth, they actually appear to be about the same size in our sky, which is why our moon can eclipse the sun during the total solar eclipse. A little bit more subtle than that, because again, sometimes it's at apogee, sometimes it's at perigee, depending on where it is in its orbit. So the moon's size in our sky can vary up to 14%. If it's at apogee, it'll be about 14% smaller than it would be at perigee. So in a scenario like this, we can get a total solar eclipse. But if it's like this, if the moon were at apogee, it wouldn't be big enough to cover the disk of the sun. And in that particular case, we do not get a total solar eclipse. We get what's called an annular eclipse. We had one of those back in October 14. It was an annular eclipse. Annulus is the Latin term for ring. So sometimes they call this a ring of fire eclipse. So again, you see the moon covering the disk of the sun, but it doesn't completely eclipse the sun. And we get an annular eclipse. And I was fortunate enough to see this eclipse in Ely, Nevada. Brian drove out too. He saw that one, not too far from us. And we were part of a team from Exploratorium that had been tasked with setting up telescopes and broadcasting this eclipse for people around the world. Turns out the Exploratorium is a museum in San Francisco. And through funding by NASA, they do eclipse expeditions around the world. They've been doing this for 25 years. And they hire teams to do a television broadcast, and now, of course, a YouTube broadcast of the eclipse. And so this is what we did for the annular eclipse. And when I say we, it's my buddy Rick right here. He did the lion's share of the work. I was basically just kind of tagging along. I put the deal together, he executed it. And they liked him so much that they invited him back to do it again in Torreon for this upcoming eclipse. So Rick Honey of the Memphis Astronomical Society will be the chief telescope operator for the Exploratorium, broadcasting the eclipse around the world on April 8, 2024. Pretty cool for the Memphis Astronomical Society. And if you are interested, we do have a YouTube documentary on our experience in Ely, Nevada, back in October. So, just want to point that out. But anyway, that's an annular eclipse. If the moon is too far away to cover the disk of the sun completely, in other words, closer to apogee than perigee, we don't get a total solar eclipse. Those are nice, but the real show is what's coming up in April, 1 week from tomorrow, actually. So here you can see the two paths crossing. This has kind of been what's been promoted for the last couple of years now. We had the annular in October. We got the total coming up in April. So this is really a warm-up for what's coming on April 8th. Again, 1 week from tomorrow. And here you can see a simulation by, I think it's Ernie White of NASA, of the vantage point from the moon, just how small the shadow is, the path of totality as it crosses the planet. So most of Earth is covered in water, and the moon's shadow, the deep umbral shadow, only covers less than 1% of the daylight side of the Earth, which is why very few people ever get to see a total solar eclipse in their lifetime. On average, 1 in 10,000 people ever see a total solar eclipse. Most of the time the path is over water or it's over a remote part of land. So it's very rare to see a solar eclipse. I had to wait 33 years to see my first total solar eclipse. And the shadow, you know, most of the time you're either chasing the shadow, traveling thousands of miles to go on a remote expedition to see a solar eclipse. It's very rare for the shadow to come to a place that's convenient for you. Sky and Telescope magazine, this month, April 2024, they're featuring an article on eclipse expeditions from the 19th century. This is an interesting one. How far would people travel to see a solar eclipse a century or two ago? Circa 1883, among the remotest sites to which American and French solar eclipse expeditions traveled was Caroline Island, a tiny coral atoll, now part of the independent Republic of Kiribati, located some 2,100 miles south of the Hawaiian Islands. Caroline Island was almost on the center line of the eclipse of May 6, 1883, and experienced nearly 5.5 minutes of totality. Round trip, the 22-member U.S. English expedition, whose camp is shown here, took 101 days and covered more than 24,000 kilometers. So eclipse expeditions were quite an undertaking, to say the least, in the 19th century. Risk and reward. Even with careful planning and preparation, there was no guarantee of success or survival. James Melville Gillis led a 4-man U.S. Navy expedition to almost Peru for 1 minute of totality on September 7, 1858. While crossing the formidable windswept desert, deep sand desert, Peru's Sakura Desert, he became so severely dehydrated that it almost seemed to collapse. Quote, whilst lying upon the ground, he wrote, I instructed my young friend as to each portion of the telescope until it was satisfactorily mounted. Another British astronomer, Father Stephen Perry, traveled to Salute Isle off the coast of French Guiana to observe the total solar eclipse of December 22, 1889. He felt so ill with dysentery that on E-Day, he had to be carried to his instrument so he could observe. 5 days later, he died. So people have died trying to see a solar eclipse. So I tell people, you know, you live right here in Memphis, very close to the path of totality. What's your excuse? Here it is. Again, we're talking about the deepest part of the moon's shadow, which is where all the action occurs. For this particular eclipse, it's about 124 miles wide. It starts in Mexico, crosses into Texas, of course up into Arkansas, southern Missouri, Illinois, Indiana, Ohio, across the Great Lakes, and then out to sea. Moon shadow travels about 1,800 miles per hour. A little history of eclipses. The ancient Greeks and Babylonians independently discovered something called the Saros cycle. And here you can see a mechanism of an ancient Greek computer that was recovered in 1901 off of the island of Antikythera. It's thousands of years old, and it was likely used by the Greeks in the classical period to track the sun and the moon and their relationships, including eclipses. So they understood that there was a regular pattern to eclipses. long before basically the realm of modern science. And the Saros cycle is essentially an alignment that where an eclipse geometry repeats itself every so often. So to break this down, I told you that the moon orbits the Earth every 29.5 days on average. It's a little more subtle than that. That's actually the synodic period, new moon to new moon. So it's where the moon is located in our sky relative to the stars or relative to the sun. It actually takes slightly less time than that to get from perigee to perigee. Again, perigee being the closest point in the moon's orbit around the Earth, or from node to node. So 27.2 days for the moon to get from node to node, 27.5 days to get from perigee to perigee, 29.5 days to get from new moon to new moon. Why does it take slightly longer to get from new moon to new moon? Because the Earth is also moving around the sun, so you need that extra couple of days for the moon to catch up, so they have it lined up with where it is in the sky to our sun. Here's the punchline. If you look at the period at which these occur, and you line it all up, every 6,585 days and change, which is the equivalent of 223 synodic months, the same as 239 anomalistic months, which is the same roughly as 242 draconic months, you have the same eclipse path repeating itself on Earth. That breaks down to every 18 years, 11 days, and 8 hours, that eclipse geometry repeats itself somewhere on Earth. So the eclipse that we've got coming up next week on April 8th is actually part of a family of eclipses, the Saros. In this particular case, it's part of Saros 139. It's a family of eclipses that began in 1501, and it will end on 2763. So this is eclipse number 30 in that Saros cycle. So the world, of course, looked a lot different in 1501 compared to where we are today. America had just been discovered only less than a decade ago. Young Nicholas Copernicus, considering revolutionizing the world by reintroducing the heliocentric model. That was happening in 1501. And we're not even halfway through this Saros cycle, this family of eclipses. You can see the geometry here. The last one in this Saros cycle was actually March 29, 2006, and it occurred over North Africa. So you can see here the path of the eclipse we got coming up next week compared to the one in March of 2006 over North Africa. The next eclipse occurs in 2042. So now what's even more interesting is every 3 Saros cycles, that eclipse occurs in roughly the same geographical location on Earth. So, as an example, we had this eclipse 7 years ago on August 21, 2017, across the country. You go back 54 years, it's the same path, same Saros cycle, as the July 20, 1963 eclipse. Why do I point that out? In 1963, there was an 11-year-old boy who saw a partial eclipse, that eclipse, in New York City. And he was so inspired by that eclipse that he decided when he got to high school that he would travel for the next total solar eclipse 7 years later, March 7, 1970. And as a result of seeing that eclipse, he decided that every opportunity he would travel anywhere in the world to see a total solar eclipse. March 7, 1970 was his first eclipse. He's now getting ready to watch this eclipse 54 years later in Mexico. Same Saros cycle, Saros 139. He's now seen 30 total solar eclipses on every continent around the world. He's probably the world leader in eclipses. He's Mr. Eclipse, Fred Espenac. Isn't it interesting that as an 11-year-old boy, he was inspired by a partial eclipse that was part of the same family of eclipses as the one we got on August 21, 2017. And his first total solar eclipse as a high schooler was in North Carolina, part of the same Saros family as the one that we've got coming up on April 8th. That's why I'm encouraging people, if you have young kids that are either in elementary school or junior high school, maybe they have an interest in space, try to get them into the path of totality. Because I won't make the one in 2078. If we look ahead, 3 Saros cycles from right now, May 11, 2078, the eclipse that we're going to see in April repeats in roughly the same geographical location, further south, over New Orleans, Alabama, Atlanta, those areas. But maybe we have kids who are 9 or 10 years old today who will be in their 60s when that particular eclipse occurs. And maybe they'll be inspired to be the next Mr. Eclipse. Who knows? So anyway, all that to say, there's a regular pattern to eclipses, and there is somewhat of a cosmic significance. So when you think of it in terms of serial cycles, it's kind of interesting. The other thing about this eclipse is it's a little bit better than the last one. So the one that we got coming up in April occurs the night before that eclipse. It's actually true perigee for the moon. So that means the moon is going to be closer than it was for the August 21, 2017 eclipse. You get a slightly larger moon, slightly longer duration. So maximum duration for the one we had 7 years ago was about 2 minutes and 40 seconds. For this eclipse, maximum duration is about 4.5 minutes. So more time in the moon's shadow. All right, so here it is. Again, this is a different Saros, but on August 21, 2017, that was our last total solar eclipse. And you can see here, most of us saw this eclipse. And the reason is because we didn't plan one specific event, but we gave our members sort of the freedom to travel and go wherever they felt best. So we had people that saw it anywhere from Oregon to eastern Tennessee. I was in Lebanon, just east of Nashville. That was not my original plan, but the clouds sort of dictated otherwise. I had 2 minutes and 32 seconds of duration during totality. You can see here, this is the telescope I used. I actually am using the same scope again for this eclipse. And we had families with their kids coming by to look at the sun during partial phases. Started out cloudy, but as the eclipse progressed, the clouds dissipated. There's actually a scientific reason for that. But the upshot of it is it was clear during totality and we were able to see it. Here's a picture that one of our members took from Paducah, Kentucky. And again, the partial phases, it starts with first contact when the moon first touches the disk of the sun. And for the first hour and 15 minutes or so, not a whole lot is happening. You're basically just seeing the moon slowly move over the disk of the sun. You can see some sunspots here. This will be a pretty active solar disk for the one we got coming up next week. So if you're looking at it through a telescope or through binoculars, solar filter binoculars, you should see lots of black spots. Those are sunspots on the disk of the sun. When you get to about 20 minutes before totality, things get really interesting. So you see these pictures were taken in Memphis. They did not have a total eclipse in 17, and they won't again here. It's a deep partial. But a lot of the same effects when you get about 15 or 20 minutes before totality. So again, here you see the moon mostly covering the sun. The sun is like a crescent now. The light begins to change. It becomes dimmer, tired, kind of a muted light, if you will. The colors begin to change in the sky, and the shadows change also, become crisper. I'll explain kind of the details of what that looks like. But if you're near trees, and it's sunny, and the light is being filtered through the leaves of those trees, you may see crescents being projected on something, whether it's a white poster board, or maybe a white wall or something. Just kind of fascinating. You can also do this with your fingers. You can just mesh them together. One of our members did this in Cape Girardeau, and you just see little crescents forming. So another thing you can do is take a colander from your kitchen that you use for straining pasta. You guys know what this is? Anybody eat pasta or spaghetti or anything? Most of us have this under our kitchen sink, or you just pick one up at the Dollar Tree. And if you, during the deep partial phases of the eclipse, if you align it with the sun, you should see little crescents forming on the ground. So you can have some fun with this. So it's a fun way to view the partial phases. And in Ely, Nevada, they got real creative. Somebody had a round disc with broken mirror glass, and then you could turn it and then project crescents onto a wall. So that was kind of fun. I mentioned the shadows also. Again, you're about 15 minutes from totality. You're looking at a crescent sun. If you're looking at shadows, anything that's parallel to the crescent, the edges of the shadow will be really sharp and really crisp. anything that's perpendicular to the crescent, the edges of the shadows will be fuzzy. So it's kind of an interesting effect to look for just before totality. Another effect that I just became aware of, thanks to Gordon Telephone, is the Purkinje effect. So it turns out that your eye processes light differently in daylight as opposed to nighttime. So during daylight hours, the cones are primarily responsible for processing light, and they're skewed more toward the reds and the yellows. But as you get toward the nighttime hours, moments before totality, where the light is more muted, the cones take over, and that light is skewed more toward the greens and the blues. So the upshot of it is, wear bright colors on eclipse day, your reds and your greens, and you may notice the colors being kind of muted and dimmed and mushy and bland, if you will. So I didn't notice this for the last eclipse, but this may be something we're looking for as an effect during the deep partial phases as we get into this one. Just before totality, about a minute or so, the diamond ring appears, and this again is where the moon has mostly eclipsed the sun. You're seeing bright sunlight still shining through the edge of the moon. Now at this time, again, the moon is eclipsed the sun about 99%, but it's still very dangerous to look at the sun during this phase because the sun is still bright enough to do damage to your eyes. You're still looking at a sun that's about 10,000 times brighter than a full moon. So definitely need to wear your eclipse glasses. And then Bailey's beads, this is seconds before totality. The moon is not completely smooth. It has mountains and valleys on the edge of the moon, so you're looking at sunlight being filtered through the deepest valleys on the edge of the moon. And this is just before totality. And then, of course, you're plunged into this kind of this deep, eerie darkness. This was my experience for the last eclipse, 2017, just before totality.
All right, we're 1 minute away. 1 minute away from totality. Here comes the shadow. Here comes the shadow of the moon. There's Venus right there to the right. There's Venus. No way. No. Got it. No. Okay, here it comes. Here comes totality. You got it. Here it comes. Here it comes. All right, here we go. Just getting dark. Wow. Here it is. Oh my gosh. Look at that. Venus. Wow.
Is that what you have picture of Venus?
This is unreal. Here comes the corona. Not yet, not yet, not yet.
I can see it.
See it? There it is. Okay. There it is, guys. Right here. Now look at the sun. Look at the sun. Look at that sun. Look at that corona. And to the left, you see Regulus. There it is. You guys see it, eh? You see it to the left.
Oh, there's a star on the left.
Look at that corona. Look at that corona. That is unbelievable. Look at those streamers. Unbelievable. I see a prominence at 5 o'clock. Wow. That is amazing. Look at the twilight. Here's Jupiter. Jupiter right over there to the left. Yep, that's Jupiter. What is Jupiter? That's Venus. That's Jupiter. Venus to the left, Jupiter to the right. Look at that corona.
about 2.5 minutes to work with. Every second counts during totality. You can see kind of how I spent my time during totality. So once you get past the Bailey's beads and the moon blocks the photosphere of the sun and it goes dark, it doesn't get completely dark. Maybe like a deep twilight, you can see that you get a 360-degree sunset all the way around the horizon. Bright stars and planets appear, Jupiter, Venus, and whatever else is out. I spent the majority of my time looking at the sun with my naked eye. So during totality, it is safe. If you're in the path of totality, you could never do this in Memphis because we're outside the path. But if you're in a spot, again, in the path of totality, during totality, it is safe to look at the sun with your naked eye. It's the only time you can see the corona. And you can see a picture here. I'll show you several pictures of the corona taken by some of our members. Freddie took this one in Perryville, Missouri. Ross took this one in Cape Girardeau. And we can show you some of the best pictures of the corona from astrophotographers in the world. And nothing is a substitute for what your eye will see. Because it's not a static thing. You're seeing you're seeing solar streamers as a result of charged particles moving along magnetic field lines of the sun's outer atmosphere. And it's just a magnificent sight. So I spent, probably 60% of my time just staring at that corona. It's the only time in my life I can do it. I also took regular handheld binoculars, no solar filters. Again, during totality, when the moon blocks the sun, and I looked at that moon through my binoculars, and I could see prominences, I could see the solar streamers up front, I could see the bright star Regulus in Leo during the eclipse. And these are prominences. One of our members took this picture from Kentucky. Again, during totality, you're seeing eruptions from the sun's surface. And this was a mystery for a long time. Back in the 19th century, they didn't know what these were. They didn't know if it was part of the moon or if it was part of the sun. They didn't understand what the sun was at that time. But you see these pinkish and yellow and red flares, if you will, on the edge of the sun during totality. It's really intriguing. So that's the real reason why we put forth so much effort to get into the path if we can during a solar eclipse. Sarah's here. She took probably my favorite eclipse picture ever. She was in Dover, and you can see not only the eclipse sun, but the scene around the eclipse. She was in a remote location, so she got the wildlife effects. And you can see here the color of the corona, the pinkish color and some of the white and everything else. She blew this up and gave this to me as a canvas, and that's when I kind of got a clue that maybe she liked me. I got a Waffle House picture in there also, just because it's the South. So it's not this one down here. It's just some random one I snagged off social media. Again, this is one of the best pictures of the corona ever taken. From Sky and Telescope magazine. Rick Feinberg, he was in Oregon. So you do some really amazing things with astrophotography. The best camera is your eye. You got to protect it, but again, during totality, you got a few minutes to see that corona. It's an amazing experience, and you can get really creative if you want to. A little more history. This is a sketch of the corona that was taken from the July 29, 1878 eclipse from Pikes Peak by Samuel Langley. And this is the first time that they really started to understand that the corona, the outer atmosphere of the sun, could extend for hundreds of kilometers, or millions of kilometers into space. So Langley observed the eclipse from the summit of Colorado's Pikes Peak at an altitude exceeding 4,200 meters, well above the densest part of the lower atmosphere. So this would be like the ideal spot, right, to see a solar eclipse. This is maybe the most famous eclipse in American history because of all the astronomers that were there and just because of the setting. Colorado had only been a state for 2 years. And at the base of Pikes Peak, this picture was taken. Maybe the most famous eclipse picture of that time. And then this is a quote of what they saw during totality. Quote, "The scene was now one of surprising beauty, for Pikes Peak far away to the south still remained in sunlight, looming in rosy outline, while the horizon that a moment before was ochre now glowed with red, gold, pink, and lilac. Stars and planets came out like a corona, gleaming with a pale nebulous light, and the heavens above acquired a shade of blue that mortal cannot describe." Magnificent. All right, let's get into a little bit more solar eclipse safety here. So again, this is very important. During a total solar eclipse, in Memphis, there will never be a time when you can look at the sun without eclipse glasses. I've got a pair up here. Feel free to take as many as you need. They are available for free. If you're in totality, those 2 to 4 minutes, depending on where you are, you can take your glasses off. No filter. Look at it with the naked eye, and then of course on the back end, you got to put your eclipse glasses on again. So, again, a little crosstalk here. So we have the solar eclipse glasses here. They're made by American Paper Optics. And if you go to eclipseglasses.com, you can order them, or you can get them here for free. We still got plenty of pair left. I got to do a little bragging. American Paper Optics is right down the street, right here in Bartlett. They're the #1 distributor of solar eclipse glasses anywhere in the world. I was able to tour. I was invited to tour their plant just a few days ago, and there were a couple of members of the president's cabinet that were there also. You can see here a picture of me with John Jarrett, the president of American Paper Optics. I'm just saying. They're getting national attention. They also made an app for your smartphone. So if you want to take pictures of the partial phase of the eclipse with your iPhone, there's an app for that. It's called the Solar Snap app. And basically the way it works is take a little filter with either a piece of Velcro or tape, and put it over your camera, and then you open an app that allows you to tweak either the exposure, the zoom, or the focus, and then you can just zoom in on the sun and take some fairly decent pictures, if you will, of the sun during the partial phases. And I created this video, and as a result of this video, they've asked me to do an interview on Fox Weather. So, I'm just saying. But anyway, that's how you use it. It's very simple. And the app is about $13. You can get it from eclipseglasses.com. And the app is available for free. So, you can see I used this for the annular eclipse, and some of the pictures I took. Again, these are not DSLR quality, but they're not bad either. And it's a lot cheaper than spending thousands of dollars on the equipment that you would need to take professional images. So, if astrophotography is your thing, this is probably not. But for a lot of people who are just ordinary iPhone users, this is not a bad solution. Solar Snap app. Again, American Paper Optics. They make it. Go to eclipseglasses.com or just right down the street. I like the Sunoculars. So these are solar filtered binoculars, and these are great for looking at the sun. And of course, you can see detail on the solar disk, including sunspots. So you don't necessarily need these just for a solar eclipse, but they're great for the partial phases also. So this is kind of my go-to tool, if you will. They do sell for $129. Eclipse, the website greatamericaneclipse.com, they're sold out there, but you can still get them on Amazon. And of course, you're not a real eclipse enthusiast unless you have all 4 colors. So, just saying. You can also do pinhole projection. Now, this is not something I necessarily do. Mylan has created some pretty good examples of this that we've been doing for the schools that we've been doing this presentation around. Well, basically, you need to take just a simple piece of cardboard or backer board, if you will, punch a hole in it, and then just project the solar disk on the ground. It's a fairly safe way to view the partial phases. You can also take a cardboard box, cut a little hole out of the back, put a piece of foil over top of it, poke a small pinhole in that foil, and then hold the box up over your head opposite the sun, and then it'll project a small image of the disk inside that box. And again, it's an indirect way of looking at the sun without exposing your eyes potentially to any damage. So the glasses, of course, are always a good way to do it. I'll mention this also. During totality, this would be a great exercise for kids. I've not done it, but another thing you can do, especially if you're near the center line and you have 4 minutes to work with, you can sketch the corona. Debbie Moran spoke at our group back in August. She's another eclipse chaser. She's been around the world, seen 15 total solar eclipses going back to the early 80s. Her first eclipse was in Indonesia in 1983. And she was a young girl at that time. She sketched the corona and noted where the prominences were, and then also that there were a couple of bright stars and planets out, Betelgeuse and Mars at this particular time. So that that time during totality goes really fast. Whether it's 2 minutes like we had in 2017, or even if you get 4 minutes like the one we got coming up, it'll feel like 8 seconds. It'll go that fast, and it's really hard for your brain to remember what you saw. So if you sketch the corona during totality, it'll make it easier. When I say easier, it'll kind of help preserve the memory of what you saw a little bit better. And it'd be interesting, especially if you do it when you're young, to look back on this maybe decades later if you see another one. Okay, little terminology here. There are 4 contact points for a solar eclipse, a total solar eclipse. So first contact occurs when the moon first touches the disk of the sun. For Memphis, it's around 12:37. Second, when the partial phases unfold for about 1 hour and 15 minutes or so. Second contact is when the moon reaches the other side of the sun's disk, and that's where you get the diamond ring, the Bailey's beads, and then you're plunged into the darkness, and that's when totality occurs. So that's second contact. And that lasts for maybe 2 to 4 minutes, depending on where you are. Third contact is the back end, when the moon moves off of the sun disk, and then you get Bailey's beads and diamond ring on the back end, and then the eclipse is over, and you're basically on the back end, partial phases. So that's third contact. And that lasts for about 1 hour and 15 minutes. And then fourth contact is when the moon finally moves off the sun's disk and the eclipse is over. So what does that look like? Here's a simulation of what you're going to see in Memphis compared to Jonesboro. Again, Jonesboro is only an hour and maybe an hour and a half drive from here. It's in the path of totality. Memphis is just outside the path. You can see here what you would see if you were looking through a telescope or your goggles, your solar glasses. So first contact begins about 12:37 p.m. in either location. You can see here we're progressing through the partial phases of the eclipse. A little after 1 o'clock. Not much is happening right now. Not until we get to about 1:40, if you will, 15 minutes before totality. So you can see here we're just 120, 120, 121. So the moon is slowly moving over the sun's disk. So you got time, if you're observing the eclipse, to basically do whatever. You want your equipment set up on time so that you can observe you can observe first contact. But notice the difference. Now we're getting close to totality. Watch the difference between what you can see in Memphis, 97.4% versus Jonesboro at 100%. So maximum eclipse in Memphis occurs about 1:57 p.m. So we get a deep partial, a deep crescent, but watch what happens in Jonesboro. We get the corona and we get totality. So that's the difference between being in the path versus not being in the path. So we don't get second contact or third contact in Memphis. We get a deep partial, but you get all 4 in Jonesboro. And that's why we've been encouraging people, especially since we're so close, to make the short drive to totality if you can. So on a scale of 1 to 10, if you were to rank the 3 types of solar eclipses, a partial, an annular, or a total, experientially, a partial would be a 3, an annular would be a 7, and a total would be a 10 million. So the message is, get into the eclipse path if you can. All right, bright stars and planets, this is another simulation. Again, we're looking in Jonesboro, Arkansas. I'm using a program called Stellarium. And I'm looking at the sun here just before first contact. It's 12:32, April 8th. I wish the skies would look like this, but we'll talk about that in just a second. You can see here the moon just starting to move to the sun, and first contact is about to occur. So first contact occurs at 12:38. You can see it taking that first notch out of the sun. So the moon is starting to move across the solar disk. So now we go forward in time. If I back out here a little bit, I can see the sun and the moon lining up. And I'm just kind of resuming here for the horizon. Again, I'm assuming I'm in Jonesboro, Arkansas, around the time of first contact, 12:30. Now I'm going forward in time, 1 o'clock, 1:30. So I'm getting into the deep parts of the partial eclipse. So 1:32, 1:34, 1:40. Now when I get to about 1:50, things get interesting. So the moon has mostly covered the sun's disk. Still get a crescent, still daylight, the light is beginning to change. Now watch what happens as I go forward. If I go forward a couple minutes, again, if I'm in Jonesboro, totality is going to occur around 1:55. So I zoom out here, 1:51 p.m., the light is beginning to change, the sky is beginning to change. It's still daylight, but now I'm going to go forward and watch the transformation as we get into totality here. Again, right at about 1:55. So I'm going forward. So it happens pretty quick. You go from basically, the bright sky to totality. Again, I'm right around the time of Bailey's beads, 1:55 in the afternoon. And that really show that now totality begins. Now, if I zoom out, what do I see in the sky during totality? If you look to the lower right, you should be able to see the bright planet Venus. And Saturn and Mars will also be out also. I just kind of zoom in here on Saturn. You won't see this detail, but if you can look at Saturn through a telescope, you basically see the rings essentially edge on, and maybe you can see some of the moons. But you'll basically just see Saturn as a dim point. Venus should be pretty bright and noticeable on the lower right during totality. And that's because Venus is mostly full during totality. So Venus is pretty bright when you see it. And then the other planet that's out is Jupiter. It's in the upper, you're looking at the eclipse sun, it'll be in the upper left. If I zoom in on Jupiter, again, if I could look at it through a telescope during totality, the great red spot will be out, in addition to the 4 Galilean moons. So, of course, that's not the best way to spend your time during totality, but isn't it interesting that during totality, the great red spot could be theoretically visible on Jupiter. There's also a comet. Comet Hans-Brooks, a little bit higher up in the sky. If you have binoculars and you know where to look, you might be able to see that comet during totality. So that's kind of interesting also. It's in the constellation Pisces. I didn't show that. I'm a Pisces. My birthday was last month. If your birthday's in April, you're probably early April, you're also a Pisces. And we got some other bright stars visible in like Orion also. I don't know if we'll be able to see those, but it's pretty interesting to look and know where stuff is in the sky. Again, in Jonesboro, you got about 2.5 to 3 minutes to work with. So as we get to 2 o'clock, then the eclipse ends, and then it becomes daylight again. So even in Jonesboro, toward the edge of the path, you've got about 2 minutes and 40 seconds of duration during totality. So that's not bad. It's pretty good. And then, of course, at 2 o'clock, the eclipse ends. Everybody starts their engines, and you get a traffic jam as everybody's trying to leave the eclipse path at the same time. So, again, this is what you see, just kind of snapshot. Lower right, Venus, a little lower on the horizon, Saturn. Upper left, Jupiter, and that comet, Hans-Brooks, possibly if you have binoculars. Why totality? You're going to miss a lot of stuff if you don't see totality. No sudden temperature change, no sudden plunge into darkness, no Bailey's bead, no diamond ring, no chromosphere, or prominences, no corona, no sunset, nothing. So even at 99.9%, keep in mind, the sun's really bright. A million times brighter than the full moon. During totality, the corona is about as bright as the full moon. The sun's photosphere is 1,000,000 times brighter than the corona. So even at 99%, you're looking at a sun that's 10,000 times brighter than it would be during totality. Even at 99.9%, a lot of people think that's really good. You're still looking at a sun that's 1,000 times brighter than it will be during totality. In Memphis, we're at 97.6%. The sun is 24,000 times brighter than it would be in Jonesboro, Arkansas. So put forth a little effort if the conditions are right to get into totality. All right, so I got these slides up here for climate and weather. This has been part of my presentation for the last several months. Basically, the higher up you are, the worse your chances are in terms of percentage of cloud cover. The lower you are, the further south you are, the better your chances. So this slide is now completely worthless. The reason is because we have an advanced forecast. So this is what it looked like a year ago, on April 8, 2023. You can see this is a very dicey time of year. But if the eclipse had occurred a year ago, we would have seen it in Arkansas. Another shot of the eclipse path. I took this shot just a couple hours ago before I put this presentation together. You can see here, this is what we are all getting very anxious about. This is 1 week before the eclipse. Again, I've been waiting 10 years for this one. I waited 33 years for the last eclipse. So many of us have been obsessing over this eclipse. Now we get a week out and we see something like this, and it's just very depressing. So it's hard to sleep, it's hard to concentrate, it's hard not to think anything negative. Because I look at this and the entire path is now in the clouds. So, but this will change. We're watching it closely, and we're just kind of hoping and praying that we get some spot that opens up relatively close to Memphis. But the reality of eclipses is you got to chase them. And we've seen advanced forecasts that show Niagara Falls and Buffalo, New York are suddenly back in play. So success is always inconvenient. So how far do you want to go and how much pain do you want to suffer to actually see this eclipse? Well, that's the real question. That's what we're going to try and find out in the next few days. So, again, I put this slide up here to kind of envision a four-pronged attack from Cape Girardeau down to Texarkana. It's another slide that's completely worthless because it doesn't look like Arkansas or northern Texas are necessarily the best spots right now. Hopefully that changes. We do have a front moving in. It's just a matter of how fast that front is moving and how the forecast is going to change as we get into the next week. But if Cape Girardeau did work out, you would have about 4 minutes and 7 seconds of totality, which is really good. Jonesboro, I mentioned this earlier, about 2 minutes and 36 seconds. You get further west of Harvey, 4 minutes and 12 seconds. We have a group that's planning to go there, if it's clear, to the scout camp out there. For comparison, if you went straight along 40 toward Conway, about 3 minutes and 53 seconds. So they have a big event planned, NASA does, I think at Russellville. But again, the advanced forecast is highly questionable right now. So now we look at other parts of the path further north. I did not think Indiana, Ohio, certainly not New York would ever be in play. I wasn't even thinking about those. But this is what happens with weather. It can force you to change your plans real quick. Vincennes, Indiana is on the center line, 4 minutes and 5 seconds of totality. It's about a 6-hour drive from Memphis, not including stops and traffic, so you probably want to double that for the eclipse. And it's ironic that I'm from Michigan, and Ohio and Michigan are two states I never want to set foot in again, and yet I may have to consider that in order to see this eclipse. Suddenly Cleveland, and maybe even Erie, Pennsylvania, are in play again as well. But I've never seen the Rock and Roll Hall of Fame, and the Guardians have an opening baseball game that day, so maybe Cleveland isn't a bad choice. I don't know. Okay, we're going to wrap up here. I want to mention a couple of apps for your phone to help you plan very precisely for the eclipse. All right? The first one is Totality by Big Kid Science. So just go to your app store, whether you have an Android or an iPhone. I use iPhone. And download this app. It's a very easy app to use. It's free. And basically all you do is you click the start button and it brings up an interactive map of the eclipse path. And then you can just zoom in. I'm sorry, you had a question? Okay. So just go into your app store, search for Totality. Very easy to use. And it not only gives you an interactive map of the eclipse that you can zoom into, like down to the detail, like mile marker, not mile marker, but topography, terrain, buildings, whatever. But it gives you the exact timing of your location down to the second. How long the eclipse is, and then when each of these contact points are. So you're looking to target a specific spot. I can tell you to the second, as an example. First contact begins at 11:58 and 26 seconds. So this is probably the easiest app to use, Totality. There's another app called Solar Eclipse Timer. This is developed by Gordon Telephone. And the app itself is free. You do have to pay a couple bucks for the data for the eclipse. But this app will speak to you. You load it up, and you just click Select the Eclipse at time. click to get your GPS location. It'll enter it into your phone where you are, and then the app will audibly speak to you throughout the eclipse. It'll say, first contact in 1 minute. We'll do this. Second contact in 1 minute. Observe for shadow bands. Remove your filters if you're photographing the eclipse. So it talks you through each stage of the eclipse. I've never used it. I've practiced with it, and it's very convenient. So the idea is, drive to wherever you're going to see the eclipse, open the app, click this button, click that button, 2 clicks, and then you're ready to go. And then the app will basically talk you through the eclipse. All right, Sky Telescope, we're promoting this magazine. They have a special issue devoted to the eclipse. $10, Barnes & Noble, or you can order it online. Some good information. And if you're wondering when the next eclipse is, if this one either does or doesn't work out, August 23, 2014. You can see here, it just grazes Montana and North Dakota. Now, if you don't want to wait that long, you can see that same eclipse 1 solar cycle earlier in Spain. So that's your sales pitch to your wife. Honey, we're going to Spain. In a couple of years. That looks like a fun trip too. So. Anyway, that's it. That's all I got. And I'll take any questions or comments or feedback. Thank you very much.